Hey guys, so yesterday we talked about the law of sines and the law of cosines. So today we're going to dig a little bit deeper into the law of sines because there is going to be a case where the answer you get isn't always as straightforward as you think that it is. So that's going to be called the ambiguous case. And with the ambiguous case with the law of sines, what it's telling you is sometimes there's going to be a second answer and sometimes only one answer is going to work. With that, also, there's going to be times where there's no triangle that's even possible with the law of sines whenever it gives you the information. So, I have listed over here all of the different possible options. Um, these are not something you're going to have to memorize. It's just something that you're going to have to double check as you're using the law of sines. You're going to have to go through and make sure there's not a second answer that's possible, and you're going to have to make sure that your answer actually works. So the way that you're going to do that is you're going to double check that your smallest angle lines up with your smallest side and your largest angle lines up with your largest side. So you just need to make sure that your sides and angles are matching up. So here's our first example, and we're just going to go through and see what happens as we're trying to solve this problem. So we have triangle ABC, so let me label out A, B, and C. And then it tells us angle A is 30 degrees, so this is 30 degrees. The side across from angle A is 7, and the side across from angle B is 16. Also, I just have a general triangle down here. You're not going to worry too much about what the sides actually look like on the triangle. Just focus on the numbers. I know that this side is technically shorter, but this could be any triangle. You can just sketch one on your paper. So what we're looking for is angle B. So to find angle B, we're going to use the law of sines. So we're going to have the side little a, which is 7, over the sine of angle A, so the sine of 30. And that's going to equal side little b, which is 16, over the sine of angle B. And that's what we're looking for. So then we're just going to cross multiply to start solving out for angle B. So we're going to have 7 times the sine of angle B is going to be equal to 16 times the sine of 30. And then to get sine B by itself, we need to divide by 7 on both sides. So we would have the sine of angle B is equal to 16 sine 30 over 7. And the last thing that you have to do to solve for angle B is just go ahead and take the inverse sine. So sine inverse of 16 sine 30 over 7. And then you're going to type that into your calculator. So starting out, again, go ahead and make sure your calculator is in degree mode. Mine already is. So now I'm going to go in and I'm going to type inverse sine of, and I want to get my little fraction bar in here to make it easier to see everything. And I have 16 sine 30, and then I need that divided by 7. And when I hit enter, it tells me there's an error. So whenever that happens, and if you look back over and make sure that all of your work is correct, that means that no triangle can be formed that has these dimensions. So this gave me an error. And so what's going to happen there is for angle B, there's going to be no solution. And so that is the first case with the ambiguous case where 0 solutions are possible. So then now we're going to start with example 2, and I'm still going to just go ahead and label my triangle first. So I have A, B, C, and I have the measure of angle A is 30 again. Side A is 10 this time, and then side B is 16. And it wants us to find angle B. So we're going to go through with pretty much the same process we did on the last one. So we would have side little a, which is 10, over the sine of 30. And that's going to be equal to side little b, which is 16, over the sine of angle B. And so now I'm going to cross multiply. So I have 10 times the sine of angle B is equal to 16 times the sine of 30. And this time I just need to divide by 10. So I would have the sine of angle B is going to equal 16 sine 30 divided by 10. And again, just like on the last one, to finish solving for B, we're going to take the inverse sine. So sine inverse of 16 sine 30 over 10. And so I'm going to go to my calculator and I'm going to type that in. So I need second sine for sine inverse, and I need the fraction bar in there. And I have 16 times the sine of 30 divided by 10. And I want to solve for that. And so this time I do get an answer. It's 53.13 degrees. So what I'm going to do is I'm going to put the 53.13 in our triangle for B. And then I want to make sure that this is able to work out. So I want to go ahead and find angle C as well. So to do that, I'm going to do 180 minus our 30 degrees from angle A and minus the 53.13 for angle B. And I get that angle C is going to be 96.87 degrees. And so as of right now, this looks like it could work out as a triangle. I do want to check to find side little c to make sure that that's going to be my longest side, because I need my longest side to be across from my biggest angle. So really quick, we'll find side little c. It's going to be over sine 96.87. And that's going to be equal to, and we're just going to use A again because that's the one that was given. So we'll use 10 over the sine of 30. So this time when we cross multiply, we'll get C times the sine of 30 is equal to 10 times the sine of 96.87. And I'm going to divide by the sine of 30. And so when I do that, I had 10 times the sine of 96.87, and then I divided that by the sine of 30. And that gives me 19.86 for that side. And so that is longer than the other two sides, so my largest side matches up with my largest angle, which is one thing that I wanted to double check. So then we have this other note over here, and that says the sine of an obtuse angle is equal to the sine of its supplement. So that means we have the sine of theta, and that's going to be equal to the sine of 180 minus theta. So that is going to be the thing that you have to check to see if there's another option for angle B in this triangle. So I have option 1 right here where B equals 53.13. And we're going to keep that, but I am going to go back and erase the numbers out of my triangle so that I can see if there is another option that is available for angle B. So the way that I'm going to do that, essentially, is I'm going to take my original angle B that I got, which is 53.13, and I'm going to subtract it from 180 and see if it fits in the triangle. So I have 180 minus 53.13. So that gives me the supplement to the original angle B that I found. And I'm going to come to my calculator and type that in. So 180 minus 53.13. And that gives me 126.87. So to double check that 126.87 is going to fit in the triangle for angle B, we need to find angle C. So angle C would equal 180 minus 30 minus 126.87. And I need to find that answer. So I would have 180 minus 30 minus our 126 that we just got, and we get 23.13 for angle C. So if we get an answer for angle C that's positive, then that means that the 126.87 does fit in the triangle. So an alternate answer for angle B is going to be 126.87 degrees. And that's going to be kind of how you check it. I'm going to show you another example where it's not going to work out, so you'll know when you only have one solution. But basically, if you have two solutions for an angle, it means that one of them is going to be the supplement of the other. So let's do one more example so that you can see a time when that doesn't necessarily work. So we have A, B, and C again. So let's fill those out. And we have that A is 30 degrees, side A is 20, and side C is 16. And it wants us to find angle B. And looking at that, I think that is actually a typo because there shouldn't be, there should be side little b instead of C. So the 16 should have been for side little b. So let's change that to B and put our 16 over here. And then we'll go from there. So first we want to find just regular angle B, not worrying about if it has a supplement or anything like that. And so I'm going to have side little a, which is 20, over the sine of angle A, which is 30. And then I'm going to have side little b, which is 16, over the sine of angle B. And I need to solve this out. So I'm going to have 16 sine 30 is going to be equal to 20 sine B. And so I need to divide by 20 on both sides. And I'm going to reverse the order of this so that I have sine B on the left-hand side. So I have sine B is going to equal 16 sine 30 over 20. And so for B, you're going to need the inverse sine of all of that. So 16 sine 30 over 20. And so I'm going to find that on my calculator. So second sine, and get my fraction bar in there. And I have 16 sine 30. And then divided by 20. And that's going to equal 23.57, about 5/8. So I'm going to do 23.58 for angle B. So then I need to find the supplement of angle B and see if that will fit in the triangle. So the supplement is going to be 180 minus 23.58. And so that is going to equal 180 minus our previous answer is 156.42. And so I'm going to put that in for angle B, and then we need to check and see if we can still find angle C. So for angle C, I would do 180 minus angle A, which is 30 degrees, minus angle B, which is 156.42. And that would equal 180 minus 30 minus our previous answer is negative 6.42 degrees. And so this is an example of where the second case does not work. So that means the angle C would be negative 6.42. That can't happen because you can't have a negative angle in your triangle. So in this one, the only answer choice that does work correctly is angle B equals 23.58. So then I want to go over a case like this. This was one of the released NCFE questions from when the class had an NCFE. And so it has triangle WXY. So I'm going to go ahead and label it WXY. and it says angle W is 14 degrees, and the vertex at X is obtuse. So obtuse means it's greater than 90 degrees. And then the side opposite of vertex W has a length of 7, and the side opposite of vertex X has a length of 9. And it wants to know what is the approximate length of the side opposite vertex Y. So that's going to be this length right here is what we're looking for. So the first thing that we have enough information to find out is the angle X. And so I'm going to use the law of sines to find that. So I would have side W, which is 7, over the sine of angle W, which is 14. And then that's going to be equal to side X, which is 9, over the sine of angle X, which is what we're trying to find. So I'm going to go ahead and solve for X. So I would have 7 times sine X is going to equal 9 times sine 14. I'm going to divide by 7 on both sides and take the inverse sine, and I would end up getting X equals inverse sine of 9 times sine of 14 over 7. And so I'm going to come in here, do inverse sine, and then actually I'm going to go ahead and get my fraction bar in here. And, oops. There we go. And I would have 9 times sine of 14 degrees divided by 7. And that's going to equal 18.12 degrees. So then this is where we're going to run into our issue, is we got the angle X is 18.12. But according to our description, vertex X is obtuse. So that means it needs to be greater than 90. So 18.12 obviously is not greater than 90. So what I want to go back and look at is the supplement of our 18.12. So I'm going to do 180 minus 18.12. So 180 minus our previous answer is going to give me 161.88. So let's go back, and that is greater than 90. So I'm going to come in here and fill in 161.88 for angle X. And then to find side Y, I still need to find angle Y. So I'm going to do 180. Okay, my calculator froze a little bit, so give me a second on that one. Okay, so I couldn't get my calculator to start working, but what I needed was 180 minus 161.88 minus 14, and using Google, that gives me 4.12. So I'm going to come back here, and Y is going to equal 4.12 degrees. So I'm going to put that in, and then since we're able to fit angle Y in the triangle, we already know that this ambiguous case is going to use the supplement of the angle, and that part is going to work. So now the last thing we need to find is side little y, and that's going to be over the sine of 4.12. And it's going to equal, we're going to use W because that's what was given. So we have side little w is 7 over the sine of 14. So we would cross multiply and get y times the sine of 14. And that would be equal to 7 times the sine of 4.12. And so then to get y by itself, we're going to need to divide by the sine 14 on both sides. And so y is going to equal 7 times the sine of 4.12 divided by the sine of 14. So let's go type that in. Okay, so when you type all of that in, 7 times the sine of 4.12 divided by the sine of 14, you're going to get 2.078. And just a note, if you're typing these into Google, you have to actually physically type degrees or it will find the answer in radians. So we're getting that y equals 2.08, which is answer B if you're looking at the multiple choice answers on the released NCFE. So then, just to wrap everything up, whenever you're dealing with the ambiguous case, there's three possibilities. You could get 0 triangles, like none of them work. You could get 1 triangle where you found an answer, but then whenever you found the supplement of the answer, that doesn't fit in the triangle. Or you could have 2 triangles where the supplementary angle does fit in the triangle. So the original angle you found and the supplement are both solutions. So keep that in mind. And then I also don't know if I actually mentioned this in the beginning. The ambiguous case with the law of sines is only going to appear whenever the sides and angles that you're given follow the pattern side-side angle. So you're given 2 sides, and then the angle that you're given is not contained within the 2 sides. So that's just something else to keep in mind as well as you're looking through this law of sines ambiguous case.